Hi, welcome back again to my channel. Thank you so much for joining, for liking, sharing, and staying along with this new series that I am doing. So let's dive right into it. So today we are going to be talking about electron pushing mechanisms. So for my time being a chemist, electron pushing mechanisms are so important. And I noticed that for a lot of my students, electron pushing mechanisms are normally the most points on literally every organic chemistry test. And sometimes just getting a few of these, it's very helpful. But also, from what I've noticed, is that understanding the mechanism is really key for you to predict the products, for you to fill in reagents and everything. So it's overall very important. It's one of the key things that a lot of instructors try to test their students to see if they understand their transformation or not. So let's start with A. So looking at A, it seems like one of the method groups basically migrated. So what we will do is basically move this method group over here. So this is basically called a methyl shift. There's a hydride shift, which is like a hydrogen shift, but there's also a methyl shift. So by moving this methyl group 1 over, this carbon now becomes positive charge, which is what we see over here. So that's pretty much all you need to do for A. Now let's do B. So B is a little bit simple because they already gave you the arrows. So all you have to do is just kind of predict the product. So looking at B, it looks like this alkene, we're going to use this alkene to come pick up this hydrogen. At the same time, we're going to take the bond, which is the 2 electrons that are hydrogen chlorine shared, and we're going to put that onto the chlorine. So we know that chlorine is going to be a minus now. And we also know that we are going to pick up an extra hydrogen here. So this hydrogen can go on this carbon or this carbon. It makes sense to put it on this carbon because if you put it on this carbon, you're going to get, it makes sense to put it on this carbon. So let me go ahead and just number this. It makes sense to put it on carbon 2 because if you put the hydrogen on carbon 2, then you get a secondary carbocation. But if you put the hydrogen on carbon 1, you get a primary carbocation, and that's high in energy. And I can draw these intermediates for you. Okay, so if you look at this, if we put the hydrogen on 1, we get a primary carbocation, high in energy, not favorable. If we put it on 2, we get a secondary carbocation, high. It's okay, it's still high in energy, but it's better than a primary carbocation. So in that case, we're gonna put this here. And that's all we need for B. Let's go ahead and look at D. So looking at D, we're going to first have to draw in the electrons moving. And then also, we also have to determine where the arrows are going to go. So this is a pretty simple acid-base reaction. So in this case, for you to figure out which one is the acid, which one is the base, we can just put the pKa's of the different ones and determine which one will be an acid, which one is base. I know that carboxylic acids are normally 5. HBr is negative 9. On the other side, the acid will be this, which will be negative 2. So between these two right here, HCl will be the acid, and then this will be the base. So let's go ahead and draw this, which means we get these as our product. Now the hard question is, let's figure out where the arrows are going to point. The arrows always follow the side with the weakest acid and then the weakest base. So looking at this equilibrium, where do you guys think the acid, the arrow will favor? I'm going to put a question mark. Comment below if you know, would it favor on the right side or the left side? I'm just going to put a question mark and see what people say in the comments side. So let's go to D. So D, it's also another problem that we have been given the electron arrows, and then from then on we have to figure out where what the products will look like. So looking at D, it tells us that this hydroxide is going to form a bond with this carbon. At the same time, we're going to use one of the double bonds, the 2 electrons, and put it on the oxygen. So now let's see what we have. So we will get this as our product. So if you're watching this and you really like some of the material that I'm covering on here, please don't forget to like, share, and subscribe. Please subscribe to this channel. Comment below with some topics that you guys think I should be covering. Let's finish up with E. So E is a radical reaction. Okay, so it seems like we're going to form a carbon-bromine bond just by looking over here. So based on that, we're going to take this, form this, and we are going to get this as our product. So that is pretty much all I have for you guys today. Once again, please don't forget to like, share, subscribe to this channel, and I will see you guys in my next video. Bye, y'all.